Hello, and this time we're looking at negative indices. And what does it mean to have 2 to the power of something with a minus sign, or indeed anything to the power of a negative number? Well, it's quite straightforward that if you have a negative power, it simply makes a reciprocal, which means 1 divided by that number to the power without the negative sign. And we'll just look at some of these examples as to what that means, and also just say that the normal rules that you have about combining indices when you times, divide, and raise powers and then further powers, they all just apply. You just process them with negative numbers. That's no different. It's just, what does this actually mean? It means it flips over. So this example here of 2 to the minus 3 is just 1 over 2 cubed. Now you could work that out as 1 over 8 if you wanted to expand that. And equally, if you have something on the bottom, so you see this in equations quite a lot, that you can say, okay, well, I've got meters per second, for example. So not an equation, but in a unit. You might have seen this, that instead of writing meters divided by second, which is what you're kind of saying by meters per second, you can say meters seconds to the minus 1. So if you have something on the bottom, if you have sort of like 3 over x, sometimes we would rewrite that as 3x to the minus 1, so that it's up on the top and we can process that in a different way. Maybe you're doing differentiation, or maybe you're just simplifying things in a different way. You can do it in reverse. Something on the denominator can come up if it then has a negative index. Just get rid of this, give ourselves more space. So I just want to mention fractions at this point. What if you have a fraction to a negative power? So let's put minus 2. Then what that's going to do is the reciprocal, 1 over a fraction, is going to flip the fraction upside down. 2 over 5. It's still got the power of 2. It's 2 now, not minus 2, because we flipped it. And of course we can just work that out. 2 squared and 5 squared, you can just do them separately, squaring the top and squaring the bottom. So, it doesn't matter what your number is, if you have it to raise to that power of minus, it does a 1 divided by. Now, I'll just very briefly show you why that is the case and how we sort of came up to sort of think about it this way. If you think about 5 to the power of 1, well, 5 to the power of 1 is just 5. 5 squared, we know that, is 5 times 5, or 25. And 5 cubed is 5 times 5 times 5, or 125. We're timesing by 5 every time we go this way. But the other way to say that is that if we go this way, we're dividing by 5. Dividing by 5. So if we divide by 5 again and bring the power down, 5 divided by 5 is 1. And so if you've forgotten, any number to the power of 0, except for 0 itself, raised to the power of 0 is 1. So anything to the power of 0 is 1. And we can keep going. If we divide by 5 again, as we move along from right to left, we're just dividing by 5. So you get 5 to the minus 1. Well, we have 1. Divided by 5 is 1 over 5. And then 5 to the minus 2 would be 1 over 5. And then divide by another 5, you're going to get 1 over 25. And so you can see it sort of appearing as a natural extension coming back from the normal powers that I hope you're happy with already. Right, let's get through these examples and see if that brings up anything exciting. So, raise a number to a power to another power. Well, this actually has nothing to do with negative indices, really. This is just something to a power to a power. And if you remember, a to the m raised to the n is a to the m times n. So we're just going to multiply these two powers together. Doesn't matter that they're negative. If they weren't, you'd still multiply them. It just so happens they are negative, and because they're both negative, we're going to get 3 to the power of positive 2, because timesing minus 2 and minus 1 together gets positive 2. And likewise for this one, it's just the rule about division, where a to the m divided by a to the n is a to the m minus n. the fact that they're negative makes no difference at all. It's going to be 3 to the power of minus 2 minus minus 1. Of course, minus minus is plus, so it's going to give us 3 to the minus 1. Minus 2 plus 1 is minus 1. And same thing here, timesing, you're going to add the powers, and then you're going to subtract that power because of the division. So it's going to be 4 to the power of minus 3 plus minus 1. Well, that's minus 4, and then minus minus 4. And then add 4, it's actually going to give us 0. And in this case, because it is a 4 to the 0, we can say that it's just the number 1. Now for this last example, it's kind of asking the other way. It's saying, well, what power would give us this? Well, there's two things going on here. There's 16 and 25 have become 5 and 4. Well, I think actually, if the 16 becomes the 4 and the 25 becomes the 5, that makes more sense. They've been rooted. So that's a fractional index. So this is going to be 16 over 25 to the half, in order to make them a 4 and a 5, to root them. But also, it's flipped over. The 16 becoming 4 has gone on the bottom, and the 25 becoming 5 has gone on the top. So we're just going to put a minus on there. And that minus, we know negative indices, is going to flip the fraction over, and then the half is going to square root each of those numbers. So that means that x is minus a half. And I would leave it as a fraction. There's no need to put it as a decimal. Minus a half is absolutely right. And certainly for powers, I would never put a decimal in unless I really could help it, because the fraction tells you what's happening. It's telling you a root of 2 and a power of something else if it wasn't 1. And so it's better to leave it as a fraction. If you have any questions or comments on those, then you can pop them down below. But otherwise, ta-ra for now.